Good morning, everyone. This is lecture number 12 in graphs, and we were dealing with position time graph in the last class. Yes or no? Do we remember this? We had seen some question on position time graph. We had seen how we can use position time graph to find out what are the things that you can find out from a position time graph. The things that we can find out from a position time graph are the velocity, the slope of position time graph gives us velocity. We can find out whether it is positive or negative. We had seen when it is positive, how the graph looks like. When it's negative, how the graph looks like. We'd also seen that if it's a distance time graph, the slope of distance time graph cannot be negative because velocity speed cannot be negative. Now that takes us to the next heading. The next heading will be velocity time graph. So please write the next heading, which is velocity time graph. I hope everyone is there in the class. Yes or no? Second type of graphs are velocity time graphs. Or velocity time graph. Now, in this graph, what is going to happen is that we are going to plot velocity along y-axis. Velocity will be plotted on y-axis and time would be plotted on x-axis. Graph is always named in such a way, y-axis is named first and x-axis is named first. Now, how does the velocity time graph? We can have different types of velocity time graph. First, we need to understand what all information you can get from a velocity time graph. What all information you can get from velocity time graph. The first thing is slope. Slope of VT graph, velocity time graph. V2 minus V1 divided by T2 minus T1. The slope of velocity time graph will give us what? It will give us acceleration. Do we understand this? Yes or no? V2 minus V1 divided by T2 minus T1. That will give us the acceleration. Do we understand this, everyone? I don't see you. I don't see the other class. I see one class, but I don't see students. I hope everyone is there. Okay, fine. The slope of velocity time graph gives us acceleration, but why the camera is panned this way and you are sitting the other way? Okay, anyways, I hope everything is fine. Okay, the slope of velocity time graph gives us acceleration. There is one more thing that you can find out from this velocity time graph, and therefore velocity time graph are more likely to come because they give us additional information. Apart from the slope, I can also find out one more thing, that is the area of a VT graph. Now, area of a velocity time graph can give us the information about the displacement It can give us the information about the displacement and the distance traveled. We can actually find out both the displacement and the distance traveled by the particle. How we can do that? If I draw a velocity time graph, let me say I draw it like this, a VT graph. This is plus V, this is minus V. If I draw a VT graph like this, from this VT graph, I can definitely find out the slope of this graph. The slope of this graph is going to give me the acceleration. The area under this graph will give me my displacement. For example, if this graph is like this, let us say this graph is like this, then I can find out this area. This is the area of a rectangle. You can find this area out, yes or no? Red one, okay. You can also find out this area. This is the area of a triangle, yes or no? Again, you can break this. This may be looking like a trapezium. You can easily find out the area of the trapezium if you know the formula. Do you know the formula for area of a trapezium? If you don't know, I mean, I don't want you to remember it. What you can do is you can break it up into two. You can find out the area of this triangle. Yes or no, bacha? Half base into height. You can find out the area of this rectangle. Yes or no, bacha? Length into breadth. So you can find out the area of this entire diagram. From the area of this entire diagram, I can find out displacement as well as distance. But to find out displacement as well as distance, remember displacement is a vector. Displacement is a vector and therefore it has a direction. And for direction, we are using positive and negative. So if I have to find out displacement, area above time axis will be taken as positive. For displacement, my dear friends, area above time axis will be taken as positive and area below time axis will be taken as negative. If I take this blue areas as positive and the red area as negative and then I add them, so negative will get subtracted eventually, that will give me displacement of the particle. If I take all areas as positive, because distance is never positive, if I take is never negative, if I take all areas as positive and then add them, definitely if I take all the areas as positive, nothing gets subtracted. Then whatever I get is the distance traveled by the particle. Do we understand this? Yes or no? No or yes? I'll give you 1 minute, 2 minutes to just note this down. After that, you just have to solve some problems and we are done. 2 minutes, note it down. Positive area, negative area, length into breadth is rectangle or square, whatever. Half base into height is triangle. That's all you need to know. I'll give you 2 minutes to note it down. Do it fatafat. Completed, sir? Okay. Then before going on to question, let us discuss about some types of velocity time graph that we might be needing and they might come as theoretical questions. Let us discuss this graph first. The first graph, remember velocity is plotted here, time is plotted here. The particle may be moving along x-axis, then it will be velocity along x-axis. The particle may be moving along y-axis, then it is velocity along y-axis. No matter whatever is happening, in whichever direction it is moving, velocity is plotted on the y-axis. We understand this? Huh? Okay. Now the simplest graph that I can draw, which is possible, is this gentleman. And as soon as I see this gentleman, there are things that I can understand from this gentleman. Gentleman number one. What are the things that I can understand from this gentleman? Look at this gentleman. What I am saying here is time is changing from T1 to T2. Remember, time always increases. It never decreases. I can't go back in time. So the particle is moving from, let us say, A to B. Let us say its velocity is v. What all things that we understand from this graph? Graph number one. I am calling this graph number one. What you can say looking at this graph? What is the slope of this graph? The slope of this graph is 0. Yes or no? It's a horizontal line. Yes or no? That means the velocity of the particle is 0. No. Slope of this graph is 0. That means the slope of this graph tells me the acceleration. So acceleration is 0. Yes or no? There is no acceleration. There is no acceleration. That means velocity is constant. Do you see velocity getting constant here? Do you see velocity is constant here? Yes or no? The graph is on the positive side. So velocity is positive everywhere. Do we see this, bacha? Velocity is positive. Graph is upwards of t-axis. Velocity is positive. Do we understand this? The area of this graph will be, if you look at the length, look at the breadth, it will be v into t2 minus t1. Yes or no? No, yes. And this will be taken as positive for displacement. Yes or no? For distance, everything is positive. For displacement, above time axis positive, below time axis negative. Do we understand this, or this is going above and saying bye bye, bye bye, bye bye, bye bye? I'm going, don't worry. And do we understand this? Yes or no? Okay. Have you drawn this, bacha? Now, if I draw this graph, if I could draw this graph, graph number 2, the slope of this graph is infinite or undefined. The acceleration of this graph becomes undefined. Is this graph possible? This graph is not possible. Do we understand? Do we understand this? Whenever we have graph which is vertical, that graph is actually not possible. Area under this graph, as you can see, is 0. It is not covering any displacement. It is not having any displacement, but its velocity is continuously changing. Velocity is changing, but no displacement. This graph is not possible. Do we understand this? Yes or no? No, yes. I'll give you 1 minute to note this down. Completed, everyone? Then we can move on and look at this graph, which I shall call as graph number, which I will call as graph number 3. Look at graph number 3. Particle is going from A to B. What all things you can say about graph number 3? The first thing you can say is velocity is positive. Always it is above time axis. Yes or no? Velocity is positive. What you can say about the slope of this graph? Is the slope of the graph positive or negative? Slope of the graph is negative. Do we understand this? That means acceleration is negative. Now you can look. Acceleration is negative, but velocity is positive. Velocity is positive, but acceleration is negative. Therefore, your velocity is going to decrease, and you can see velocity is decreasing. Do we understand that the velocity is decreasing? Yes or no? Slope of this graph is constant. Therefore, the acceleration of this particle is constant. Do we understand this? Yes or no? We understand this? So the last graph would be like this. I will call this as graph number 4. And the particle is moving from, let us say, A dash to B dash. I'll give you 1 minute to note down graph number 3. Then we'll move on to graph number 4. Once you are done, please let me know. Have you noted this down, beta?
Yes, sir.
Okay. One thing I forgot to mention here in this graph, in the first graph, to find out acceleration, we have to find out the slope of this graph. And to find out the slope, what do? We do V2 minus V1 divided by T2 minus T1. Do we understand this?
Yes, sir.
Please note this down. To find out the slope of this graph, final velocity minus initial velocity divided by final time minus initial time. So I forgot to mention that. So please note it down. Okay. So graph number 4, can anyone tell you what is happening in graph number 4? Is the velocity positive or is the velocity negative? Tell me about velocity first. It's a VT gram. Is the velocity positive or is the velocity negative? I think your mic is not working. Velocity is positive. What can you say about the slope of this graph? Is the slope of the graph positive or is the slope of the graph negative? Slope of the graph M is positive. That means acceleration is positive. Are we understanding this? Because I can't hear your voices. Are we understanding this? Yes or no?
Yes, sir.
Okay. Slope is positive, acceleration is positive. As you can see, when time increases, velocity also increases. Why is the velocity increasing? Velocity is positive in the positive direction. Acceleration is also in the same direction. That will make velocity to increase. The slope of this graph M is constant. That means the acceleration of the particle is constant. How do I find the acceleration? I find the final velocity. I find the initial velocity. Then I subtract final final minus initial, and I divide it by the total time. Do we understand this?
Yes, sir.
Okay, you may see this small graph as well. If I have to show you, have you noted this down?
Yes, sir.
So I can show it in terms of a graph as well. Here is this graph. I'm saving some time of drawing this graph. So as you can see, this one is V2 minus V1. This one is T2 minus T1. So my acceleration becomes V2 minus V1 divided by T2 minus T1. I hope everyone understands this. I'll give you a minute to note this down. Then we'll move on to some question and answers.
Yes, sir.
You are completing it so quickly. Well done. Okay, that means you have prepared beforehand. That is a very good sign that you have studied beforehand. I always keep on telling those JEE people, JEE students that the NEET one are a lot better. They are more hardworking and they are better prepared. Shall we move on to the question? Yes. This is the first question. It came in one of the engineering exams. I'm sure you are good enough to solve this, even though you are not preparing for an engineering exam. Question number 1. In the following graph, what is the distance traveled by the body in meters? So the graph is given to you, my dear friends. And I wait for a minute for your answers. Yes, my dear friends, any answers for this one?
1 minute.
1 minute is not the answer. Answer will be distance, so it will be in meters, not in minutes.
Option A, sir.
Yes?
Option A.
I can't hear you. Okay, probably you are trying to solve this question. I'll wait for a minute.
Sir, option A, sir.
Yes, Bacha, what is the answer for this one?
Option A, sir.
Yes?
Option A.
I can't hear anyone. Anyways. One. That is correct. 200 meters. That is correct. Well done. So you just need to find out the areas. What is the area of this one? Area of this one is half into base. Base is 10 into height. Height is 15. Half into 10 into 15. Then you can find the area of this two. This is simple. Length into breadth. Oh, height is not 15. Height I think is 10. 15 is wrong. Sorry. Half into 10 into 10. Here this is 10 into 10. Length into breadth. This one 3 is also half into 10 into 10. If you add all these three, because in any case it is distance, in any case it is positive, answer would be 50 plus 100 plus 50 and the answer is 200. We all get this, yes or no? Okay. Comes the next question. Remember, the language of the question may be difficult, not difficult, different at different times, but we are supposed to do the same thing always. So here is the question that comes. I hope you would be able to solve this and tell me the answer. For the velocity time graph shown below, the distance covered by the body in the last 2 seconds of the motion is what fraction of the total distance covered by it in all the 7 seconds? I'll give you 2 minutes to solve this. They are asking you to find out the ratio of the distance traveled in the last 2 seconds to the distance traveled in all of the 7 seconds. I'll give you 2 minutes to solve this.
Option B, sir.
Option B, I have an answer. Well done. And option B is correct. Option B, 1/4. That is absolutely correct. Everyone got the same answer? Yes or no? Huh? Not getting any response from anyone? Girls, boys? Okay, that obviously is the correct answer. And how are we supposed to do this? Let us find the area of all the things. Number 1, half into base is 2, height is 10. So this becomes 10. Let us find out the area of this part. 2, length is 2, height is 10, 2 into 10, 20. Let us find the area of this. It is half into 2 into 10. So this is 10. So the total distance from 0 to 7 seconds becomes 10 plus 10 plus 20. So it becomes 40. Distance traveled from 5 to 7 seconds is 10. If I have to find the ratio of distance travel in the last 2 seconds to the distance traveled overall, it will be 10 divided by 40. 1/4 is simple. Do we get this? Yes or no? Is that simple as it gets? So the correct option is B, 1/4. We all understand this? Yes or no? Now in this question, if anyone got this answer, shall I move on? Okay, now if I would have asked you in this question, so that's me to put it in this question, what is the acceleration from A to B? Or what is the acceleration between 1 and 3 seconds? Or I could have asked you, what is the acceleration at 2 seconds? If I would have asked you, what is the acceleration at 2 seconds? Or acceleration between 1 to 3 seconds. Remember, it is a straight line, so the slope is constant. So whether you find out the acceleration at 2 seconds, whether you find the acceleration at 1.5 seconds, whether you find the acceleration as 2.5 seconds, or whether you find the acceleration from 1 to 3 seconds, all the acceleration would be same. Yes or no? Can you tell me what is the acceleration from 1 to 2 seconds? How do you find the acceleration? First tell me, is this acceleration going to be positive or is this acceleration going to be negative? Is the acceleration going to be positive or is the acceleration going to be negative? It is going to be positive, yes or no? Now, can you tell me what is the acceleration from 1 to 3 seconds? How do you do it? V2 minus V1 divided by T2 minus T1. Can you tell me what is the answer that you are getting? What is the acceleration from 1 to 3 seconds? To find out this acceleration, you have to find out this V2 minus V1 and you have to find out this T2 minus T1. How much is V2 minus V1? Tell me. This will be equal to V2 minus V1. I'm writing it wrongly. V2 is 10, V1 is 0. So it will be 10 minus 0 divided by T2 is 3, T1 is 1. So it is 10 minus 0 divided by 3 minus 1. It will be 5 meter per second square with a positive sign. Do we understand this? Yes or no? So this is how we can find out acceleration from the velocity time graph. If any question comes, please don't be scared. Do we understand this? Shall we move on to the next problem? Anyone understands this? Anyone has any doubt? Shall I give you the next problem? This is problem number, I think, 3. Problem number 3 comes on your screen now. The velocity time graph of a body moving in a straight line is shown in the figure. The displacement and the distance, you have to find out both here. Displacement, blue one, the pink one, and distance, the yellow one. In 6 seconds, I'll give you 2 minutes to do this. Anyone with an answer? Shall I do it? Option 2. Displacement is 16 and distance is 8. Is it possible that displacement is more than the distance?
Yes, sir.
A sir, A sir is correct, sir. How did we get A sir? First of all, we find the area of this one. Area of this one is 2 multiplied by 4. 2 multiplied by 4 is 8. We find the area of this one. How much is the area of this one? 2 multiplied by 2. This is 4. How much is the area of this one? 2 multiplied by 2, it is 4. Yes or no? You all get this? Now, to find out the displacement, my dear friends, for displacement, this area will be taken as positive. This area will be taken as positive, but this area will be taken as negative for displacement. So once I talk about displacement, this 4 and this 4 will get cancelled and your displacement would be 8 meters. Yes or no? Or I should say plus 8 meters. When I talk about the distance traveled, all the areas are taken as positive. So 8 plus 4 plus 4. I hope you can see this. 8 plus 4 plus 4. Your answer will be 16 meters. For displacement, two areas are positive and one area is negative. For distance, all the areas are positive. Do we understand this? Yes or no? No or yes? Shall we move on to the next question? Okay. Comes this one. Let's see who can do this. Which of the following velocity time graph is not possible? You need to use your copy and pen. You can do it straight away. Which of the following graphs are not possible? A, B, C, D. Which of the following graphs are not possible? Graph number 4. That is not possible. As you can see, at any given time, it is having two velocities. It is not possible in this universe. That is why this graph is not possible. Everyone understands this, yes or no? Well done. That means we are doing great. Let me pose two more questions. Here comes the next one. Don't get scared. You might see something that you have that we have not talked about, but you know it from your ninth standard. They are talking about the force, find the applied force, but you know F is equal to ma from your ninth standard, yes or no? So don't worry about the force, F is equal to ma, you already know it. Basically, from velocity time graph, you have to find out something. From that something, you can talk about the force, and I'll give you 2 minutes to solve this.
Option D.
Yes, bacha. Any answers for this one? Option 4. Option 4 minus 1 by 3. That is absolutely correct. And how do we get this? First of all, they are talking about forces. I cannot find out the forces, but I can definitely find out the acceleration. What is the acceleration of this part? Perpendicular v2 minus v1 divided by base. No, I don't have to do that because 30 degrees given. I have to find out the tan of this angle 30 degree. Yes or no? Tan of 30 is same as v2 minus v1 upon x2 minus x1. Yes or no? So this becomes 1 by root 3. It is positive because it has a positive slope. We talk about this one. This is tan of 60. Tan of 60 is root 3. But as you can see, this slope is negative. Yes or no? I divide tan of 30 by tan of 60. 1 by root 3 is divided by root 3. So I get minus 1 by 3. And that is the answer, my dear friend, that we were looking at all of. I hope all of you got this. Yes or no? No, yes. Then quickly you will have this question and I will need the answer very, 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 very quickly. The question comes. I've forgotten the numbers. I think I will call it question number 7. 7 looks good. Question number 7, 2 minutes, solve it. Yes, but are you saying something? I can't hear you, beta.
Nothing, sir.
Sorry, I can't get you, beta. So, have you got the answer for this one? Option 1, that is absolutely correct. Option number 1. The first thing that we can see is we can find the slope. This has got positive slope. This has got negative slope and this is 0. Yes or no? Even just by understanding that one is positive, the third one is negative, and the second one is 0, you can straight away say that the answer is A. Yes or no? You can find out. So the first graph, it is positive, it will come as 5 by 10 by 10, so plus 1. Second graph has got 0 slope. Third graph has got negative slope. Height is 10 and width or base is 20. 10 by 20 is 0.5. It's got negative slope. So that is your answer. Yes or no? Okay, then we move on to the last graph, which may not ever come, but since it is a part of your curriculum, so you must do it. It is known as acceleration time graph. Acceleration is plotted on the y-axis and time is plotted on the x-axis. The slope of this AT graph, which no one will ask because that is not a part of your course, give something which is known as jerk. This jerk is the rate of change of acceleration with time. So you can write it as A2 minus A1 divided by T2 minus T1. No one is going to ask you that jerk. Area of AT graph gives us change in velocity, and that is what you must understand. It gives us change in velocity, not the velocity. Change in velocity means delta V. That means V2 minus V1. So just remember the area of this graph gives us the change in velocity. Do we understand this? Yes or no? No, yes. Note it down and then you can just draw one graph and see how does the graph look like and what does it tell you. Acceleration is plotted on the y-axis and time is plotted on the x-axis. If I have a graph like this, what does this graph tell me? Graph number one. Graph number one tells me that the acceleration of the particle is positive and it is constant. Do we understand this, my dear friends? Acceleration is positive and acceleration is constant. If I had a graph which was here like this, oops, draw it again. If the graph would have been like this, graph number two, here for graph number two, I can say acceleration is negative and constant. Do we understand this? If it is a graph which is parallel to x or x-axis, you can say acceleration is constant. The area under this graph will give me change in velocity. Do we understand this? So I'll just give you a question based on this. If you can do this question again, remember this question may never come because it may not be falling in the section where such questions come. Okay, have you noted it down? Okay, then here comes a question which I will give you and solve it. So I have plotted acceleration along y-axis and time along x-axis. Acceleration is constant. It is given that velocity at 2 seconds is 10 meter per second. Find the velocity at 3 seconds. How will you do this? I'll give you 2 minutes, 1 minute because 1 minute is left in the class. I'll give you 1 minute to solve it. Yes, my dear friends, do we have an answer for this one? Okay, the mic is not working. Anyways, first of all, we find the area of this graph. What is the area of this graph? The area is 5 multiplied by 1. Yes or no? Length is 5 and width is 1. So it is 5. So area of this graph is change in velocity. Final velocity is velocity at 3 seconds minus velocity at 2 seconds. Yes or no? Velocity at 2 seconds is given as 10 meter per second. So velocity at 3 seconds will be velocity at 2 seconds plus 5. That will be 10 plus 5. And the answer will be 15 meter per second. Do we get this, everyone? Yes or no? No, yes.
Yes, sir.
Well done. Then congratulations. This is one of the most tough questions that can come. What mistake students do in this question is they find out the area, and as soon as you get the area, they say this is the final velocity. Remember, area of the acceleration time graph is not the final velocity. It is the difference in velocity. It is the change in velocity, final minus initial. Do we understand this? This brings us to the end of this class, and also it brings us to the end of this particular chapter, motion in 1D. In the next class, we will move ahead with the next chapter, motion in 2 dimensions. So see you there. Take care. God bless you. Bye bye.